Hello, today I want to do some power supply testing. What you're looking at here are the three power supplies I'll be testing. On top here we have my homemade dual well linear power supply. So it's got two outputs, negative, positive. It'll go up to 30 volts and it's limited to about 50 watt total output. You can build one of these for about $40-50 US, something like that. If you're interested, there's another video about that. And over here we have the old Korad KA3005D. So this is the D model, D8P model, almost the same. No difference in the performance. It's also a linear power supply and its maximum output is 30 volts, 5 amps. You can buy these online for around $100. And over here we have a LongWei. It's a switch mode power supply and it's 30 volt 10 amps. So despite being a much smaller form factor, it's actually quite powerful with a maximum output of 300 watt. And you can buy this for around $40-50 US, including shipping. The tests I want to run today are peak short circuit output current, output impedance, and dynamic load testing. To test the peak short circuit current, we'll be using a test setup like this. So over here we have our power supply. We're going to set it to 10 volts, limit the output current to 300 milliamps. Then on the outputs here we will connect the switch, and then we'll have a shunt resistor, 100 milliohms, and then we're just going to short the switch here, and then we're going to use a scope here, and then we can have the scope trigger on the voltage rise here, and then we can see what is the maximum current. So we know if we have 100 milliohms here, then every 100 millivolt we measure over here is going to be equal to 1 amp. However, it does get a little bit more complicated because we cannot just use a mechanical switch. I have tried it, but you're always going to get some bounce on the switch as it makes contacts, and then it breaks, and then it makes contact again. So we need an electronic switch to get a nice clean output here. So instead of a simple mechanical switch, we'll be using a MOSFET here to do the switching. So basically I have made this tiny little circuit here where we do have a mechanical switch here, but once I switch it on, it just charges up a capacitor. Then we have a MOSFET driver here, and it's got a Smith trigger on the input, so we get a really clean switch, and then it will power the gate with as much power as it can deliver to make sure we get a really clean switch. And then we have our shunt resistor over here. I'll just show the schematic for this really short. You can have a look at it if you want to build one yourself. Okay, first I hooked up my homemade power supply here, and I've set the voltage to 10 volts and the current limit here is set to 300 milliamps. And then I try to put the scope in view here so you can see what's going on. So I'm just gonna set the scope to capture and see if we can capture it here. Bang, there we go. So what we see here is the short circuit pulse, and currently the scope is set at 200 millivolt per division. So that means it's actually 2 amps per division here. So we have about 5 amps peak. However, it's only for a very short period of time. The time per division here is only 50 microseconds. But still, it's 5 amps. It's a lot more than the configured 300 milliamps current limiting. And next, let's do the Korad. So it's set to 10 volts, 300 milliamp limiting as well. I'll switch on the output. You can see there's no load currently, and trigger the scope and see if we can capture it here. There we go. So see, that's a lot more. So here we have 2, 4, 6, 8, 10, 12, 14 amps up here. And the time period is a lot longer as well. Let's just see. That's 200 microseconds, 400, 600 microseconds, something, before it returns down to the actual set current. So that's quite a spike. So why is there a difference in the spikes here? Well, I I know because, well, I just built this, the output capacitor here is only 1 microfarad, whereas as far as I remember, in the Korad, the output capacitor is 330 microfarad, and that's probably realistic with the peak we're seeing here. Okay, so I moved over to the LongWei switch mode power supply. Again, it's set to 10 volts output, and I'll limit the current to 300 milliamps. So we can't see it right now. We can see it when it shorts. So let me just trigger the scope here. Let's see if we can capture it. Bam. Yeah, that looks a lot worse. Let's see if we can capture what's going on here. It's certainly a lot longer time. So we do get a lot of noise here because, well, it is a switch mode power supply. Let's just try again with time here. No, that's still not enough. Try one more time here. Okay, we need a little bit more there. There we go. Just move a little bit here. But now we are like 10 milliseconds per division. That's 10, 20, 30, 40 milliseconds before it returns to normal. We can see here is 2, 4, 6, 8, 10, 12, 14 amps up here. So it looks like it's reacting very, very slowly to the outputs being short-circuited. So actually it peaks out here. That's probably a capacitor. But then it looks like it continues switching here. It's trying to keep up with deliver as much current as it can. And then finally switches off and the capacitor discharges. So it looks like it reaches all the way down to 0, and then it looks like it kind of restarts, and then it starts going into constant current mode. So that's a bit of a yikes. It's definitely something you need to be aware of when using this power supply. It's not for use with sensitive electronics, but it's still great when you need a lot of power. And if we take a look at the results combined here on a single chart, it's quite clear the homemade power supply here comes out as the best with this small 1 microfarad capacitor. It's still a 5 amp peak here, but it is gone in a very short time. Here we have 2 amps per division and 100 microsecond per division this way. And the Korad comes second with close to 14 amp peak here, but still it is discharging fairly quickly, something like 500, 600, 700 microseconds. However, the LongWei is a complete disaster in this test here. It also peaks out around 14 amps, but it continues to deliver high current for 40, 50 milliseconds before it comes under control and starts going into constant current mode. So that's a bit of a failure for this test here. So the Korad performance here is probably fairly typical for most linear power supplies. You might say, hey, but I have an HB Agilent key site power supply and surely it must perform much better, but we can try have a look at a few. First here is the Rigol DP832, and it's got 1000 microfarad on the output. So in this test it will probably perform worse than the Korad. And here the Agilent E3631A, also fairly popular power supply. It's got a dual real 25 volt output and a 6 volt output. And on the 25 volt outputs we can see that 470 microfarad on each output here. And on the 6 volt output there's 1000 microfarad. And here we have the HP E3614A, and we look at C2 here. That's the output capacitor. Is anywhere from 1000 microfarad down to 220 microfarad, depending on model. So the peak short circuit current does not necessarily improve with a more expensive or brand name power supply. So why do they put these large capacitors on the output? Well, it is to increase stability of the power supply, and it will also improve other parameters of the power supply. For the LongWei switch mode power supply, I don't really have anything to compare it against. It's the only switch mode power supply I have with current limiting. So if you have a different switch mode power supply and you performed a test like this, I'll be very interested to hear your results. Suppose a comment below. For the next test, we'll be measuring the output impedance of each of the power supplies. So to do that, I'll be using my small analog discovery impedance analyzer. If you're interested in building one of these, I have a video on it. Just do a search on my older videos. However, we cannot hook it directly up to the power supply. We need to have a DC blocking capacitor when we do it. So that means doing calibration, I'll be doing an open short calibration, and open calibration will just be like this, but in the short calibration I will include the capacitor here. So that means the capacitor will be eliminated through calibration. And then I'll be adding a couple of resistors just to have a constant load on the power supply. These are two 150 ohm resistors, so 75 ohms in total. I'll be keeping the power supplies on the same setting, 10 volts output limited to 300 milliamps. I don't think it's that important, but let's just keep it the same. And here's a quick look at what the setup looks like. And here we run the measurement. Here I switched over to the Korad power supply, and we run the next measurement. And finally, here's the LongWei connected, and we run that measurement. In a power supply, you always want the output impedance to be as low as possible. So we can see here my homemade power supply. This trace here is the one with the highest output impedance, so it is about 100 milliohm higher than the other power supplies. And we can see the Korad here and the LongWei here. So the Korad and the LongWei, they're fairly similar in their performance on the output impedance. So I could probably, with a small modification, I could lower the output impedance of my homemade power supply by about 100 milliohm because I have the amp meters shunts there in series with the output. So if I move those to be part of the current adjustment loop, then we could probably eliminate about 100 milliohm on the output impedance. But anyway, this measurement, this is how I build it. I would say the Korad probably comes best here, followed by the LongWei, and then last comes the homemade power supply. For the final round of testing here, we'll have a look at how does the power supplies react to quick changes in load. So this is kind of the setup we'll be using. So it'll be two resistors here. One is a constant load, so I'm using a 150 ohm resistor here just to give a small constant load. And then we'll have a switch, and then we'll switch in a smaller resistor. So here I'm using a 20 ohm resistor, and this will be switching on off, so we can see how the power supply reacts to changes in load. And then we hook up the oscilloscope over here so we can see what's going on. To perform this test, I've designed a small circuit here. It's very simple. Here we have our two resistors. This is the 150 ohm resistor. This is, well, combined it gives about 20 ohm. And for the switching here, we're using a MOSFET, and to generate the switching signal here I'm using a 555 timer, and it's configured to run at approximately 10 Hertz, and the duty cycle is approximately 50%, meaning it will be off and on in approximately equal time period. So I'll just quickly show the schematic for this here. It's very simple, just in case you want to build it or just to give a full understanding how it works. And using this setup should give us a good understanding of how the power supplies will react to changes in load, both while remaining in constant voltage, but also when we're going from constant voltage into constant current. So the changes between these two resistors here will force the power supply to go into constant current mode, so we can see how quickly does it react. So for the first test, I hooked up my homemade power supply. I'll set the output voltage to 10 volts and I'll limit the output current to 800 milliamps. And I'm gonna start the switching now. And we can see over here on the scope, so the scope is set to 500 millivolts per division. So I'm keeping it in DC just so we can really see what's going on here. So we can see there is a variation when the load kicks in. So I don't know, it's about 100 millivolt or something like that. It's not too bad, but it's certainly noticeable. I've now switched over to the Korad power supply, same settings, 10 volts, 800 milliamps, current limiting, and let me just switch on the output. And here we switch on the switching. So we can see here the Korad deals much better with it. There's hardly noticeable any change here. You can see some very small spikes, but it's almost nothing. Same settings. So here we can see the advantage of using a larger capacitor on the output and having a lower output impedance or resistance. And I've switched over to the LongWei switch mode power supply. Same settings, the output voltage is 10 volts and the current is limited to 800 milliamps. And I start the switching now. So we can see, well, there's a lot of switching noise here from the switch mode, but we can see there are small variations. It can be a little bit hard to pick out because of the noise, but actually there is a rise and fall in voltage with the load. It's perhaps a little bit less than the homemade power supply, but it's very close, maybe 50 to 100 millivolts here. Again, but it's not horrible. However, it is noisy. So I would say in this test the Korad comes out on top, probably followed by the LongWei and very closely followed by the homemade power supply. And for the last test here, I've set the output voltage to 15 volts and I've limited the output current to 200 milliamps. So in this test I want to force the power supply to switch into constant current mode and then back into constant voltage mode, and we'll see how quickly it does that. So here I'm switching on the load. So here with the homemade power supply we can see it reacts very quickly to changes in load. There's basically no undershoot, no overshoot. This is an excellent result. And here I've switched over to the Korad, same settings, 15 volts output, limited to 200 milliamps, and I'll switch on the output. And we can hear the relay inside is going completely crazy, but actually when we look at the output here, it kind of looks okay. It is a little bit slower than the homemade power supply, but it doesn't do anything wrong. It's an okay result. However, I'm not sure how long the relay is going to last if we keep it sitting like this, but it does the job. And here we have the LongWei switch mode power supply connected. Output voltage 15 volt, current limited to 200 milliamps, and I hook it up now. So we can see it's actually very slow, much slower than the two other power supplies. So it looks like it actually reacted very slowly to being switched on, and there was even like a spike on the current here. I'll just try to do it one more time. Switch on here. Yeah, we can see the current goes up here, and it actually takes a long time before it goes into constant current mode. So I think there's one more thing I want to try here with the LongWei. It is to see what happens when we switch on the power supply. See, we switch it off here, switch it on, what happens? Let me just try, make it a little bit slower here so we can see what's really going on. Switch off here again, that looked okay. Switch on here, yeah. So you can see it actually goes full voltage before it starts current limiting, not good result. So in this test, the homemade power supply clearly comes out on top, closely followed by the Korad, and very far behind is the LongWei. So that's the last test I'll be doing today. I might come up with other tests and maybe do another round of testing. So I hope you found it interesting. I kind of want to do these tests because these are not the kind of tests you usually see when people are reviewing or looking at power supplies. So if we're going to do some kind of conclusion, I would say the homemade power supply up here, it's not very powerful, but well, it does have two 30 volt outputs, and you can't put them in series. You get one 60 volt output, and it's very quick, very nimble, but not very powerful. Then we have the Korad over here. So this is probably like more of a workhorse power supply. It really doesn't do anything wrong. All tests came out okay. It's actually a nice power supply, and it's reasonably powerful with 5 amp maximum output. And then I'll say the LongWei here is very powerful with its maximum 10 amp output, but it is extremely slow, and it can be risky to use it with some of the behavior it's got. You cannot rely on the current limiting to switch in quickly. So let's say you have something hooked up and you're probing around and you accidentally short something out, then if your circuit is sensitive electronics, then you might actually burn something out because it is too slow to go into constant current mode. I hope you enjoyed these tests. If you have any questions in the comments, if you have done similar tests yourself, you have suggestions on other things I should try test on these 3 power supplies, leave a comment below. If you like the content, subscribe and give a thumbs up. So thanks for watching, and I'll see you next time. Bye bye.